Welcome to RK Tutorials. Solutions to Engineering Mechanics 5th edition. S. Timoshenko, D.H. Eng, J.V. Rao, Sukumar Patil. In this video, we will solve problem set 2.1, problem number 2.12. In level flight, the chord AB of an airplane wing makes an angle alpha is equal to 5 degrees with horizontal as shown in the figure. The resultant wind pressure on the wing for such conditions is defined by its lift and drag components. L is equal to 6675 newtons and D is equal to 819 newtons, which are vertical and horizontal respectively as shown. Resolve this force into rectangular components X and Y, coinciding with the chord AB and its normal respectively. The formula or concept that is required to solve the problem is rectangular components. Any force F can be resolved into two different forces if the angle between those two forces is 90 degrees, then it is called rectangular components of forces. If the angle between those two forces is not 90 degrees, then it is called general components of forces. First consider this force. Let this force F makes an angle theta with the horizontal. You can resolve this force into two components. One force is along x-axis, another force is along y-axis. The angle between this x and y-axis is 90 degrees, hence I can say it is rectangular components. What is the component of the force along x-axis? Remember, here the force F makes an angle theta with the x-axis. Hence, the x component is cos component, and that magnitude is F cos theta. F. And similarly, the component of the force along y-axis is Fy is equal to F sin theta. And what about the directions? A thumb rule I am saying for directions. If force is divergent, these two forces are also divergent. If this force is convergent, these two forces are also convergent. What do you mean by that? For example, if the same force I want to resolve here, this is my x-axis and this is my y-axis, and this makes an angle theta with the horizontal. Clearly you can see, as far as this point is concerned, this force is convergent. Hence, the two forces, one force act along x-axis, this is Fx, direction is this one, Fy direction is this one. All three forces must be convergent. But here, all three forces must be divergent. That is the thumb rule you can remember. Let us consider this second one. The same force F makes an angle theta with the y-axis. We would like to resolve this force along y-axis and x-axis. Since angle between x and y-axis is 90 degrees, we can consider these are the rectangular components. What is the directions of this force? Fx, this is divergent, and Fy, this is also divergent. All three are divergent. And what is the magnitude of the forces? Fy. Since this F makes an angle theta with the y-axis, y component becomes cos because it is adjacent. and the other component becomes sine. This is a thumb rule you can find. The first thumb rule, all forces must be either convergent or divergent. The second thumb rule is the adjacent side component becomes cos. Since this force makes theta with the y-axis, so y component becomes f cos theta. Similarly, let us consider this force F. This makes an angle theta with the y-axis. I would like to resolve this force into along x and y-axis. Angle between those two is 90 degrees. Since here also F is divergent, those two forces components must also be divergent, Fx and Fy. Now here, this force makes an angle theta with the y-axis, hence the y component becomes cos theta, horizontal component becomes sin theta. Same force, for example, I want to resolve here. Can you able to understand now? The same force I want to resolve here. As far as this point is concerned, this force is convergent and this makes an angle theta with the vertical. So the two components of the forces, one force is acting like this, another force will act like this, and this is of course Fx is equal to F sin theta, and this is Fy is equal to F cos theta. Okay. Now let us take the last case. There is a force F which makes an angle theta with the x-axis. I want to resolve this force F. So as far as this point is concerned, this is divergent. So my force components are also divergent, and this also makes an angle theta with the x-axis. Hence, x component becomes cos and y component becomes sin. So Fy becomes F sin theta and Fx is equal to F cos theta. So these are the rectangular components. Now, in this problem, there is a flight which is not horizontal. This makes an angle alpha is equal to 5 degrees with the horizontal. Now the wind force is acting on the flight along vertical and horizontal, namely lift and drag force, with some magnitude 6675 and 890 newtons. Now our aim is to identify what is the net force acting along x-axis and what is the net force acting along y-axis. So what we will do is, we will resolve this L force along x and y axis, and we will resolve this drag force along y and x axis. First let us consider the lift force by resolving the lift force along x and y axis. Let us redraw that x and y axis. Let us transfer that x and y axis onto a separate plane. So this is my y-axis. I am transferring to this on a separate page, and this is my y-axis. This is x-axis. This is my x-axis. I want to find the net force along x and y axis. So first I am considering L force. What is L force? Given that L force is vertical and this makes an angle alpha with the y axis, which makes an angle 5 degrees with the y axis. Now let us resolve this force L is equal to 6675 along y and x axis. From the concept of this convergent and divergent, the force F is divergent, hence the force along y-axis and x-axis, and the direction of these forces are like this. This is the direction of force Lx, and this is the direction of force Ly. And what is the magnitude of this force? Since the force F makes an angle 5 degrees with y-axis, Ly becomes cos component, that is Ly is equal to 6675 into cos 5, which gives the value of 6650. And the other component, that is Lx, becomes sine force, that is 6675 into sine 5, which is equal to 581.8 newtons. These are the components of the forces along x and y axis as far as L force is concerned. Similarly, we will resolve that D force along x and y axis. Once again, I am transferring the x and y onto some separate space. This is my y axis, and this is my x axis. I am transferring, this is my x axis. Now I would like to resolve D force, hence I am drawing the D force now. The D force is given that D force is horizontal, and also given that makes an angle 5 degrees with the x axis. So we can resolve this D force along x and y axis. So what is the direction of this component of force along x axis? Fx. This is the direction of force along x axis, divergent, that is dx. And similarly dy, the component of force along y axis, dy, it is also divergent, so it is acts like this. And what about the magnitude? Since the D force makes an angle of 5 degrees with the x-axis, dx becomes cos component, that is 890 into cos 5, and dy becomes a sine, that is equal to 77.6 newtons. So these two forces are the component of D forces along x and y axis. Already we have resolved that L force along x direction and y direction, Lx and Ly, we have some values. Let us overlap these forces onto the x and y axis. My Lx is like this. I am just overlapping this force here. And my Ly is like this. And my Ly is like this. And the magnitude of Lx and Ly also known to us. Now, what is the net force acting along x-axis? Dx force is acting towards right side. The Lx force is acting along left side, but both the forces acting along x-axis only. Hence, the net force along x-axis is equal to dx minus Lx. That means 886.61 minus 581.8, which gives 304.8 newtons. Net force acting along x-axis is equal to 304.8 newtons. Similarly, let us find the net force acting along y-axis. dy is acting upwards, Ly is acting upwards. Hence, the net force along y-axis is equal to dy plus Ly, and this is 77.6 plus 6650, which gives the value of 6727.6 newtons. What is the final answers? If this is my x-axis and if this is my y-axis, this is x-axis and this is my y-axis, and the net force along x-axis is Fx. Finally, I can consider x, which is equal to 304.8, and the force along y is equal to 6727.6. These are the final answers for this problem. My dear friends and students, if you want the solution for any of the subject in the field of machine design, namely strength of materials, theory of machines, machine design, engineering mechanics, finite element method, mechanical vibrations. Please give the reference in the comment section so that I will solve the problem, prepare a video and upload in my channel. Please subscribe and share my video